So we were talking about inverse trig functions. We have introduced you to sine inverse of x or arc sine of x. So an easy way to understand this thing is to consider the graph of the sine. So the graph of the sine something like so if I take x is equal to if I take y is equal to sine of x, I'm going to get a picture like this red curve. If I take however, define x as the sine of y, my oscillations are going to happen around the y-axis instead. Now these two formulas are going to be considered inverse relations. If this is a relationship, you exchange x and y, you get its inverse relationship. With respect to relationships, sky is the limit. Essentially anything goes. There is no restriction that we want to impose. But when you want to deal with functions, functions are a little bit choosier and more definite. Functions in mathematics are like very tightly drawn contract, which does not allow for any kind of interpretation. Every single scenario is covered. There is no room for any dispute or having opinions and such, so on and so forth. So for any input, you want to have exactly one output. For each scenario, the contract dictates exactly what's going to happen. Well, if you want your y to be a function of x, say this is y, this is x, this black curve is not going to cooperate with us, because for any given x, I go and say, am I supposed to be here or am I supposed to be here? So that contract is not clear. Which one of these two do you want? So in mathematics, a couple of centuries ago, they decided to make everything very definite. They say, okay, this thing is going to be ruled out as a function. This black curve is not showing y as a function of x. Why? What do we want? We want it to be single valued. We want only one output. So you say we only want this portion of it so that the ambiguity is removed. Well, if you want only that portion of it, then on your original function you had to restrict yourself also to this portion. So the business of cutting up your domains and therefore perhaps choosing a section of your picture is influenced by that decision of dealing with only functions. Okay, so once it is all said and done, once from this wavy black curve you remove all the pieces except for this yellow one, the remainder kind of not all that clear what it is. You have to kind of fill up the rest of it in your mind to remind yourself what the shape was. This doesn't remind you of a curve all that much, but just try that arc sine has a picture like this, not to be confused with a graph of tangent or anything like that. So y is equal to sine inverse of x. The rightmost point of it is at 1, the leftmost point of it at -1. The highest point of it is at pi over 2. The lowest point of it is at minus pi over 2 here. Again, in your mind, just try to fill in the rest of this. There is an oscillation going on wrapping around the y-axis. We had the same story with respect to cosine. We said for cosine you have say y is equal to cosine of x, say this is 1, and then this is going to be so cosine wraps around the x-axis like this, with its high point being above the origin. If you want to have inverse relation of this thing, inverse relation of that, you say, okay, all you need to do is to exchange the role of x and y, make x to be cosine of y. In that case, you start from here and you wrap around like this. Again, the black curve is going to violate vertical line test for a y being a function of x. Y is not acting like a function of x, because if I draw a vertical line, it's going to cross it so many places. So we have to choose a piece of it to work with. So okay, here is a convention. Work with this piece. Which is a reflection of this piece. Okay, that either the yellow or the green one is chosen so that you have all cases covered, but nothing is going to show up twice. So we said that the graph of our cosine Okay, let's see if we continue here. We are talking about the graph of cosine inverse, and that is for the cosine inverse, we have a picture looking like this. Again, the right and left point of it from -1 to 1. The numbers are going from 0 to pi. So the range of values that you get here is from 0 to pi, as opposed to here where the values were ranging from -pi/2 to pi/2. So if you use your calculator to calculate sine inverse of something, the answer is going to come out to be between these two numbers. For cosine inverse, it's going to be between these two numbers. Next, we are going to take a look at tangent of x. So we are looking at this thing for the first time, graph of tangent of x. You remember that it was ratio of sine to cosine, and it had some special attributes to it that the other ones didn't have. It had so-called, what was the name of these lines? We had these asymptotes. So tangent itself is going to run something like this. So this is the tangent of x. If you talk about x is equal to tangent of y, of course, before I go any further, there are many of these tiles, is that right? So you have another one here and another one here and so on. If you want to talk about y is equal to, excuse me, let me correct myself, sorry for confused you. So this was the graph of y is equal to tangent of x. Now inverse relation of this thing is going to be x is equal to tangent of y. That simply means take a mirror image of this thing and turn it around. So instead of having vertical asymptotes, we are going to have horizontal asymptotes. Let's see what color color is left. When we reflect this across the 45-degree line, we get a picture that looks like this. But every single one of these things is going to turn over as well, and the picture gets crowded with having so many so graph of x equal to tangent of y is made out of all of these blue lines. Again, that's going to violate the notion of a function. If you want to have a function condition satisfied, you have to just pick one of these things, and by convention what we pick is this one, which means it came from this original graph of tangent that was right in the middle. So to simplify, let's restate. If I want to graph tangent inverse of x, it has two horizontal asymptotes at pi over 2 and minus pi over 2. The graph is going to look like this, just like a graph of tangent by turn around, and this is y is equal to tangent inverse of x, or written as y is equal to arctangent of x. Now if you pick any number, you plug in your tangent inverse function, it's going to give you that angle. Now that angle is going to skip the high and low that you have here, so these two are taken out of consideration. So while the domain of this is the set of all numbers, any number can be fed into tangent inverse function, the range that you get is almost from minus pi over 2 to pi over 2, except just missing just those two possible values, because you have to reach infinity to have that angle in front of you. Okay, now we need to practice some of these ideas and see how do we use any of these definitions in. Yes, question.
Why would is it impractical to have the range be infinite? You don't have a repeating value, right?
Oh, you mean have the other copies of these things?
No, sir.
No.
Have the line extend the range. Rather, why limit it to negative pi over 2?
Well, range is the values that gonna come out from our calculation for tangent inverse, or from your calculator or something. So for example, if I have, let's go back to the definition. Suppose you have the tangent of 45 degrees, you know that is 1.
I guess the domain is what I'm looking
The domain, yeah, the domain is infinite. The domain is going all the way from minus infinity to plus infinity. So no problem. So let me finish this. So arctangent of 1 is gonna be 45 degrees. Arctangent of 1 is 45 degrees. But here you were saying some limitation on the domain, which we actually don't have. It goes all the way to infinity. No problem. So we were going to talk about some applications. Let's pick some problems from here and work our way. Some of these are supposed to be answered from memory. Some others you can use your calculator to answer. Many of the new calculators actually give this answer exactly, so you might have an easy time with that. So sine inverse of minus radical 3 over 2. What is the discussion? Let's go back to our triangle that we learned in the first day of this course. Suppose you have a 30-degree triangle. What were the ratios? 2, 1, and radical 3. This was 60 degree. So which angle is it whose sine is radical 3 over 2? So sine of what angle is radical 3 over 2? So we say sine of 60 is ratio of opposite to the hypotenuse. So this missing information is 60. But this one is minus radical 3 over 2. The question is, what should be the angle? So if the question was simply sine inverse of radical 3 over 2, my answer was clear. Either 60 degrees or pi over pi third. Is that right? Either one will be fine. If it is minus radical 3 over 2, question is which quadrant are we going to be in? And the answer is yes. So it's going to be minus pi third, or that's radians, or minus 60 degrees. That is sine inverse. Yes.
Does the negative identity apply to all of the inverses?
No. Meaning what? That the
Sine of negative something is going to be the same as negative sine of something? And
you can say it like this: sine inverse of minus x is minus sine inverse of x. I guess that's what you were looking for.
yeah. Does that apply the same as with the original
Cosines and such.
cosine tangent?
Well, let's practice some of them. See, with respect to cosine, we are going to have a bit of a problem. Let me just pick an issue here. Pick example 16. That's the first one, I guess. Okay, let's do problem 16. Problem 16 is what is cosine inverse of minus radical 2 over 2. Let's give the answer for the easy case first. Cosine inverse of radical 2 over 2. What are we searching for? The angle. So we are searching for the angle theta such that its cosine is radical 2 over 2. Well, that has to ring a bell with respect to what kind of an angle? 45. 45, these ratios were cosine of 45 is 1 over radical 2, which is same as radical 2 over 2. So if that is our objective, our answer would have been easy. The answer is just pi over 4 or 45 degrees. Now cosine inverse of minus radical 2 over 2. There are lots of places where cosine is negative. Which quadrants is it? In the unit circle. Quadrant 1, of course, everybody is positive. Which one of these axes was cosine axis? This was cosine axis. Is that right? So if you have an angle here, you want to find its cosine. Cosine is the shadow of it on the horizontal axis. So if you are on the first or a fourth quadrant, your cosine is positive. Where should you be so that your cosine is negative? I have to be on the left side. So if my angle was extending anywhere here, if the cosine would have been the shadow of it on the x-axis, this cosine would have been negative. Now the question is, which one of these quadrants am I going to pick? The definition for cosine inverse, or the so-called range of cosine inverse, is to pick from where? 1 and 2. For cosine inverse, we pick these two. If it was positive, we are in quadrant 1. If it is negative, we have to choose this thing from quadrant 2. So I say my reference angle is 45 degrees, and I give the answer with respect to its supplement. So what is the final answer now? 135, you mean. Okay, so 45 degree is going to be the reference angle, and what is left is 135 degrees, or 3 pi over 4 radians. So to make this simple, cosine inverse of minus x is going to be 180 minus cosine inverse of x, or pi minus cosine inverse of x. So if you have a negative entry for your cosine, you wish you want to strip that off, but then you have to go and calculate the supplementary angle of whatever you find to force it to go into quadrant 2. Okay. How about tangent? With respect to tangent, our life is easier. Let's practice this one. Say tangent inverse of, say problem 14. See, tangent inverse of minus 1. What do you think that's going to be? Which quadrant are we supposed to be with respect to tangent? Quadrant 1 or 4. So if, let's do the easy one. Tangent inverse of 1, you're looking for an angle whose tangent is 1. Positive ones, you always give your answer in the first quadrant. In this one is easy. The angle is pi over 4 radians, or 45 degrees. If the entry is negative, then the tangent inverse by definition is supposed to be in quadrant 4. So in quadrant 4, this becomes minus pi over 4 radians, or minus 45 degrees. So tangent inverse of a negative number is simply minus of tangent inverse of positive counterpart of that number. Let's limit ourselves to just these three functions for the test and such. Also, let's just stay to that set of problems. With respect to the other three functions, you can do a roundabout calculations. You have to take a reciprocal and then go after the function. If you have a specific question, I can help you with those. Sometimes you see combinations of two trig functions or a function and its inverse all mixed up. So some of the problems you see these things. Some of them you can answer by just inspection. Some of them you have to use your calculator. Let's see. Well, before I go to problem 37, maybe let's do straightforward calculator applications. Problem 21 is asking you what is tangent inverse of 0.3673. Of course, the objective here is just to force you to go use your calculator, figure out where that button is. That's all. And how to access it. Different calculators have different styles. Some of them, some of the newer one, there is a button you press, or a combination of two of them, where the calculator right off the bat starts with an expression like this. It shows that on the display. So it guides you to type the way you see stuff in the book. They call it natural display. Then you enter your number. Now, how do you access this combination itself? Typically, there is a button there that's called tangent, and there is another button which is called second or shift or something like that. In combination of these two gets you what you want. So this might be called tangent. On top of that, there is a function written with the same color as this button. So if it is second in green, and this is written in green, means you press these two in a sequence to get that effect done. It might be called shift or something of that type. In the older style calculators, you enter your number first, and then you enter the name of your function. One way or another, you make sure that you practice a few of these things, and know where the activity of your calculator is. So tangent inverse of I am trying on my calculator to see what it gives. So 0.3673. So what do you get for that? The radians? Radians. So remember, this is the angle whose tangent is that number. Okay, I was saying that we are going to practice some of the problems with combination of these functions. So sine inverse of 0.3. So you can talk it out. Sine inverse of 0.3 is an angle whose sine is 0.3. This is an angle. It has the property that the sine of that angle is 0.3. What are we asked to calculate? We are asked to calculate sine of that angle. So without use of a calculator, I can say the answer is just 0.3. On a test, to make sure you understood this thing and you didn't just rely on a calculator to get your answer, you might have been, I might give you a quantity here. So I might say, what is sine inverse of x? That's an angle whose sine is x, and I'm being asked to calculate sine of just that angle. So the answer is just x. In other words, these two operations just cancel each other out in some sense. Sine and sine inverse cancel each other out. Whatever we started with, that's what we are ending with. Yeah, x has to be acceptable to your sine inverse. A very good point. That x has to be acceptable to very first function, and the output of it acceptable to the next function, and so on. So our x has to be limited by 1. Sometimes in the reverse, you have to be more careful. Let's practice. Tangent inverse of tangent of 2 pi third. Let's investigate the situation on the unit circle. How did we say we calculate tangents? One way to visualize tangent was to draw this axis here and say if you have any angle, so if you have opening angle here, you want to see the tangent, here's the tangent of it. So whatever angle you got, you go out until you hit this red line. Remember, this is the origin of that red axis. That's the tangent axis. You measure your tangent off of that. So suppose I have this angle of 2 pi third. How many degrees is that, by the way? 2 pi third is 120. So suppose I have this angle of 2 pi third, or 120 degrees. Suppose I want to see tangent of this. What do I do? In that direction, that of course doesn't hit my tangent axis. I come this is tangent of 2 pi third. No. We could have calculated using the reference angle. This is 60 degrees. Tangent of 60 degrees is radical 3. We are in second quadrant. Tangent is supposed to be negative. So after all of that conversation, we arrive at minus radical 3. That is, however you do this thing, you get minus radical 3, tangent of 120 degrees. Now the question is, what is tan inverse of this quantity? So what's an angle whose tangent is minus radical 3? Unfortunately, we cannot just say it is 2 pi third. That would have been a little bit too easy. What is the correct answer? It all depends on the range of tan inverse. In which quadrant are we supposed to pick our answers for tan inverse? Either 1 or 4. For tan inverse, you are supposed to pick your answers from here. So you ask the following question. This tan in this magnitude minus radical 3, what angle is it that is going to create the same tangent, but it is seated in quadrant 1 or 4? So what is this? How do we read this so that the answer will be between minus 90 and 90, or minus pi over 2 and pi over 2? No, I didn't hear any correct answer. Yeah, this is minus pi over 3. So the answer here is minus pi over 3. You have to choose this angle to be in either quadrant 1 or 4. So here, sine inverse of x is always x. We don't really need to fuss about it. But if first you have the inverse trick, then you have the trick, you have to be careful because this angle might not be in the quadrant you want to be. Okay, this angle might not be in the quadrant you want to be, and you have to talk your way to an answer, or you have to cook up some formula to answer your yes.
Though that angle is equal to pi over 3.
Yeah, would it matter which way we went?
Yeah, it does very much matter which way you are going. Try it on your calculator because calculator can handle this. Let's see. If it is easier for you on your calculator, do it. See, you're supposed to reproduce that answer. It's not.
I assume it's the same way for arc sine.
Yes. You have to land in a quadrant where the range of that function is defined to agree with everybody else. I mean, you can justify your answer, but to have a standards, have everybody agree on something, that's what we are striving for here. So your answer for tan inverse has to be in quadrant 1 or 4. Let's just make it clear. So for sine inverse, you have to land in the following range of angles, from minus pi over 2 to pi over 2, or from minus 90 to 90 degrees. For cosine inverse, your final answer has to be in the following range of angles. So it has to be from 0 to pi or to 180 degrees. For tan inverse, we have to be just like sine, except these two aren't included, but other than that you are running from minus pi over 2 to pi over 2.
So you're saying it's not just the fact that it has to land in the quadrant. No, it also can't pass in the quadrant because it's not possible to land as well.
Yeah, the angle that you give, the final numerical answer that you give, has to be between these two numbers. So other coterminal angles that end up at the same location, they are not acceptable because it's the issue of that contract that we want to spell out exactly what we all agree on, and that's what we are going to go with. So even though you can have your own interpretation that that other angle is just as good as this one, somebody else might have some application in mind where that doesn't work, and we have to stick to this.
So quadrant 4 angles must always be spoken of as a negative angle.
Yes, here quadrant 4 is not same as saying 330 degrees and minus 30 are coterminal, but these two numbers are not the same. So we want the number. We want the actual number. We don't want the coterminals of that number. We really want exactly, specifically that number. Otherwise, some bridge somewhere is going to fall. So, so the coterminals have to be pulled out of the consideration. We want the angle to be specifically in that range of, so it has to be between minus 90 and 90. Yeah, it has to be between 0 and 180. This is open interval because at that location tangent becomes infinity anyway. We don't have that. Okay, let's take a 2-minute break and then we come back and continue with the next section.